Hi, everyone. Welcome to episode number 2 of Think Like an Architect. In this episode, we'll be aligning integration patterns to use cases. And I have to say, I was just watching the chat. It's super nice to see such a big turnout, people from all over, and even a few from my own country, the Netherlands. Yay. But wherever you're connecting from, it's not a coincidence that we're talking about integration today. The reason we picked this topic is because it was the number one topic from everybody who voted about what the next episode should be about. My name is Mary McCabe. I'm a Salesforce CTA, and I'm also the leader of the architect evangelism team here at Salesforce. I'm joined today by a colleague, Gulal Kumar, of the Office of the Chief Architect. Super excited to have Gulal here. Gulal is responsible for some of the content on the Architecture Center. And notably, he's the person behind the most recent updates to the integration patterns document that was also part of the pre-read for this episode. Gulal, I'm really happy to have you here. Would you like to say a few words to introduce yourself?
Yeah, thank you. Thank you very much, Miriam, for your kind introduction. Hello, everyone. I'm Gulal Kumar, a software engineering architect at Salesforce with more than 20 years of experience in enterprise integration and platform architecture. I focus on data integrations and recently generative AI. I love sharing best practices and mentoring architects. I'm really looking forward to this discussion. It's a topic that's close to my heart. Thank you. Thank you, everyone, and thank you, Miriam.
Yeah, of course. And close to your heart. And you know everything about it, right? So, really glad to have you. So let's get into it. Episode number 2, aligning integration patterns to use cases. And as this is a Salesforce event, please remember to make any purchasing decisions based on generally available products and services. And also, while you're taking notes, please remember to save the date for episode number 3. Date March 26th. It's going to be on the same day and same time as this one. Topic still TBD, and you can vote for your favorite topic through the survey link that we will share with you. And with that, today's agenda, as part of today's agenda, we're going to start with the approach that we've been tackling in, it's going to be a refresher of the approach that we've been using in episode 1 as well. So if you're new, listen up. And if you were also with me in episode number 2, it's going to be a quick refresher. We'll then go into a specific challenge and use that approach to break down the thinking steps that I take as an architect to tackle any kind of business challenge. As I'm doing that, I'll be live diagramming the solution so that you can follow along, and also to help me take those thinking steps, because I'll be doing this live. Throughout the entire episode, we have an amazing moderation crew, and you'll be able to interact with one another, ask questions, react to the content, and we'll be answering questions both about the solution and the approach live. So let's start with the 3-step approach. So these are the thinking steps that I use to tackle any architectural problem. The first step is the what. And this is all about, and it's arguably the most important step, because this is about making sure that I understand the requirement. And as part of the what step in this episode, what I'm going to do is I'm going to take a business requirement, going to highlight keywords from that business requirement, and then I'm going to use those highlighted words to formulate that business requirement into high-level requirements. In the how step, I'll be taking those high-level requirements and align solutions to them. I'm going to do that in a holistic way. And with that, I mean one requirement may impact another. So where that is relevant, I may group some requirements together. As I go through it, I'm going to be taking notes of questions, assumptions, and decisions that I take along the way. And as I mentioned also, right, I'm going to be drawing it out in a diagram. Now, taking note of those questions, assumptions, and decisions is going to help me in the why step. And the why step can take place either when I'm done solutioning, immediately when I'm done solutioning, talking to another architect and trying to explain to them why I came to the solution that I came to. But it can also be to bring my business stakeholders along, or later down the line, years later, months later, when I'm trying to explain to myself why I took the decisions that I took. Interesting, or the key aspect here is that as I'm going through the how step, I'm already capturing those steps that will help me in the why step later on. And with that, let's get into the business requirement. So as part of this business requirement, we want to empower our service reps with a 360-degree view of 50 million historical shipment records residing in an on-premise database. There's a lot of things happening here. The things that I want to highlight is 360-degree view, because that typically implies some kind of UI unification, people not having to move from one system to the other. I'm going to take note of the 50 million here, because volumes are always an important driver for a solution direction because of limitation and constraints. They are shipment records and they're in an on-premise database. All right, let's have a look at the next sentence. So these records must be viewable and editable directly within the Salesforce UI without being replicated into Salesforce. All right, so important additional information. They need to be both viewable and editable in the Salesforce UI. Well, we saw that coming. And then without being replicated into Salesforce, that's also a key piece of information. So no replication. Let me actually just also highlight that one. So no replication. Next sentence. While historical data remains external, service reps will create and manage shipment dispute records within Salesforce to track current issues. All right, so that sounds like we're now talking about a different type of record. There are disputes about shipments, and they're both created and managed within Salesforce. All right, and so whenever one of these records is updated, next sentence, a legacy data warehouse must be notified of the record level change in near real time. All right, so on update, we need to notify a legacy data warehouse of the record level change in near real time. All right, so a lot of important nuggets there. So now that I've highlighted the key elements of this business requirement, here's how I'm going to break this down into high-level requirements. So the first one is expose 50 million shipment records from on-premise database in Salesforce without replication. And the second requirement is also about these same 50 million shipment records. And so the 50 million shipment records that are exposed require read-write access from the Salesforce UI. Okay, so I'm going to, that's additional information, so I'm going to tackle those together. And then the third one, updates to the shipment dispute records in Salesforce require a notification of what has changed to be sent to DWH, Data Warehouse, acronym, in near real time. All right, so let's get started with the first two grouped together. And oftentimes I will start with a question, but here I'm actually going to start with a decision. So I'm going to take my first Post-it and maybe a note on tooling if people want to try this at home. So I'm going through the requirements, and I'm doing the sticky notes, noting down my decisions, etc., through Lucid Spark, and then I'll be doing the diagramming in Lucid Chart. So my first decision here is that this is actually going to be, I'm going to be leveraging a data virtualization pattern. The words without replication pretty much point me directly to that. And so with that in my mind, the first question that I'm asking myself is, what does the landscape look like? What are the other systems that we have in play? Because in this particular case, I'm kind of curious, do we have a Data 360 instance? Because if we do, then maybe that would be a nice way to virtualize that data. And so let's have a look at, let's start diagramming a little bit. And I'm starting by taking a Salesforce org and an on-premises database, copying those into the diagram. And pretty much functionally, what I want to happen is I want to move the data or show the data from here into here. But I think something tells me that this is not how the diagram is going to end up. But let's just entertain the thought of leveraging data 360 here. So in this case, for this to work, we could, for example, say, okay, let's virtualize that data through like a zero copy into data 360 and then expose it back into Salesforce, leveraging data cloud 1. This is a perfectly fine pattern. However, as I'm thinking this through, I'm thinking, well, I actually know that currently data 360 does not yet support zero copy from on-premises databases. And the other thing that I know is that Data Cloud 1, whereas it's an excellent means to virtualize data in a read fashion, it does not yet support write access. So map. I'm going to remove this. And of course, I'm going to take a note because I want to remember that I went through this. And so I've actually added a limitations section to the assumptions as well, so that I can also note those down. So if I put an L colon in front of it, it's a limitation, and otherwise it's an assumption. So the limitation that I'm noting down here is zero copy not supported for on-prem. And the other one that I'm going to note down is sorry, I was actually getting distracted. So somebody is here, is chomping at the bits to already get to the OData. We're going to get to OData in a second, not to worry. So write access not supported. All right, so pretty much irrespective of whether it's part of my landscape, I'm kind of ruling it out, and that saves me that thinking step for later on. So let me just link those together so that I have the decision drivers and the decision. Let me actually just do it like that. No, I'll leave it like that. I'll forgive myself for this time. So the next question is getting to how do we then get to the data, right? So I'm going to ask myself the question, surely there must be a way that we can connect to that data. And so is there some kind of API support? And the assumption that I'm going to take is that there is a way to connect to that data. And the way that I'm going to assume it is that there will be, regardless of how old or how legacy this database is, I will be able to either leverage some kind of API or some other kind of connection mean, for example, ODBC or JDBC, and I will be able to leverage MuleSoft to connect to the database. And let me just draw that into the diagram as well. So I'm just pulling this down slightly and then dropping in MuleSoft in the middle. There we go. And so now I'm going to assume that this one, it really kind of depends on whatever this specific database is. So I'm noting it as an API, and people were already alluding to it a little bit, I am going to make the assumption that I can use, and I know that I can use OData between MuleSoft and Salesforce. And that actually introduces an additional piece to the mix that I can leverage Salesforce Connect. And the reason that I want to that I like Salesforce Connect is because it gives me some of the other requirements that are part of this overall requirements around Data 360. It's going to be able to give me some UI components to expose that data as external objects back into the Salesforce UI. And so taking notes of some of those decision points here. So I can connect, I can leverage OData, and I'll be using Salesforce connect here. So connecting those dots as well. Now, as I'm doing this, I'm also taking an additional assumption, which is around the data itself. So the assumption that I'm taking is external objects have different types of sharing than custom or normal objects in Salesforce. So my assumption here is that it is okay to share that the OWDs, the organization-wide defaults ruling the visibility of the records in the external object are public read-write, meaning that every employee that has access to the object will be able to see all of the shipment records. If this turns out to be false, that would be a decision driver for going for something else, such as, for example, Apex with LWC to limit and manage that visibility. But that's only if this is not true. So just capturing that as well. And then last but not least, in terms of all this, covering all of my bases and making sure that I've covered out all the options, I want to kind of add in my universal assumption that I always want to kind of go for whatever is most out of the box, in addition to having the lowest total cost of ownership. And for this reason, I want to go for Salesforce Connect with all of the components that I just mentioned, rather than, for example, building my own UI and Apex callout if I don't have to. So I'm going to also take a decision here, no Apex call out, connecting that back to here, and then this back to Salesforce Connect. And then I cannot and that concludes my my kind of the thinking process that I'm following for the exposing the data from the on-premises database via MuleSoft, leveraging the OData protocol, and leveraging the benefits of Salesforce Connect back into Salesforce. Now, let me just see if there's any immediate comments that I want to talk about. Yes, I see a question here around OData 2.0 versus 4.0, and that's a really good point. So if my memory serves me well, we're going to go for OData 4.0, because that is the one that also supports the read-write access, so also the writing part of the requirement. All right, and with that, let's go into requirement number 3. So this is about the shipment dispute records managed in Salesforce, requiring a notification, so a message to be sent to a data warehouse with everything that's changed in near real time. So near real time is also one of those keywords that is pointing me to already almost like to a decision. And the decision that I'm taking here is that I want to use a fire forget pattern. This is often written FF, so fire forget. The reason it's not request to reply is there is no kind of indication that we want, for example, an end user to wait for something to happen and then see something happen in the UI. And I'm also ruling out like batch type processing, because we want this to happen near real time whenever something happens. So the first question that I'm going to ask myself, taken into consideration that I'm going into fire and forget territory, is what is going to be the payload? And with payload, I mean, what's going to be the content of the message that I'm going to send? Do I want to send a snapshot? Or do I want to send a delta? And because of the, and just to be very clear on what the difference is, right? A snapshot would be like a photo or picture of the record and the fields in its current state after the thing happened. The delta would be changes to the various fields. So only what has changed. And based on the way that I already phrased my high-level requirement, I'm going to assume that it's the delta, but this is always a good thing to check with the stakeholders. and with the business. And the other thing that I'm going to assume at this moment is that it's like a simple delta, so that there is no, I don't know, express logic needed to say, oh, if this field is updated, then send these fields, or if this field was updated, then send these fields. So I'm going to say no logic in what fields to send. And so that those two assumptions are actually going to pretty quickly point me in the direction of a specific fire and forget pattern. The ones that I have available to me are, and that come to mind for me, are change data capture and platform events. And because I always like to start from the most out of the box, change data capture, which I'm going to note down as CDC, is going to have the most, is like the best candidate, because it will also manage the triggering. So whenever the record changes, and it will also populate the payload with everything that has changed. So based on the delta, CDC is definitely the best option. Now, platform events are really powerful as well. However, they are stronger if I need to manage the payload or determine what's in it, and it will also make it my responsibility to create the trigger, either through Flow or through Apex. So I'm connecting those two, and I'm actually going to say, so based on this assumption, I'm not going for platform events at this point. And with that, I think I'm almost there. The only one other thing that I want to write down here as well, again, my kind of universal TCO, total cost of ownership assumption, is that I also don't want to write any kind of Apex if I don't have to, right? So again, even because of TCO, I think that CDC is the right choice here. And so with that, what I'm going to do is I've kind of solved it all in my head, and I've done all the decisioning, but let me just actually draw that back into the diagram as well. So what we wanted to do was we wanted to send an update. Functionally, this is how we wanted to connect the line, right? Whenever there was an update to a record in Salesforce, we wanted to send that update to the data warehouse. And this is actually one of those ones where I think the line matters, right? So it's going to be from Salesforce to that data warehouse. Now, based on everything that we said, I could think that maybe this is how I would draw that out. But given we have a MuleSoft in the rest of the architecture in place, the way that I would actually solve for this is I would have MuleSoft intercept the event sent by the CDC event, and would then have MuleSoft update the data warehouse through some kind of call in to the data warehouse. And this is a solution that I'm feeling pretty comfortable about. And so leveraging whatever I put in here, in this entire kind of thought process and solution, this is what I'm going to be using moving forward to as an architectural decision record, and as a fuel for the why step. But right now, let's have a look at some of the questions that came in, and also let's bring in Galal. Hi, Galal. Hi.
Hey, Miriam. Thank you for explaining this so in simple words and simple explanation. Thank you.
Yeah, I'm hoping, let me know if I made some mistakes, right? I actually had a question for you as I was going through this, and as I was prepping for this, as I was reading the integration patterns document, there was also mention of gRPC and commit D. So the first thing that I wanted to actually ask you is, as the author of that guide, like how do those actually relate to the discussion that we've been having here?
Yeah, that's a great question. So basically, CDC and platform event both can be handled either via streaming API that is based on Comet D, or through PubSub API, that is a newer interface based on gRPC over HTTP2. So Comet is the implementation of Bio protocol, which enables long polling, and PubSub API is based on gRPC API and HTTP2, and it efficiently publishes and delivers binary event messages in the Apache Avro format. Obviously, PubSub API is a newer version and it has many advantages over streaming API, like publish, subscribe, element schema retrieval. All can be done through one API. Final publish results, when you're publishing an event to the Salesforce platform, then final published results of publish operation are sent back to the publisher and not just intermediate queuing results. Flow control can be also done when you're subscribing any events. That means you need to notify the system, Salesforce, that how many events you are capable to receive. And obviously, they are more scalable, more secure, and highly performant and real time. That's why we recommend PubSub API over Community based streaming APIs.
And just to make sure that I get it right, like, is this on the same level as CDC and platform events, or is this like I don't know, under the hood, how CDC or platform event like happens?
Yeah, so we cannot control incoming event as Gaurav. I was just looking at the chat. Yeah, we
Mm.
cannot control the incoming events from the Salesforce platform. But when we are publishing, when we are creating an integration which will publish the events, then we have luxury to choose the PubSub APIs. When we are subscribing, then we can use PubSub API. But PubSub API and streaming APIs both are the same level. Both can operate, both are able to handle CDC as well as platform events. So in nutshell, Comet D plus CDC is a streaming API, and PubSub API is equivalent to CDC with gRPC over HTTP2. So it's a
Oh,
protocol difference. Yeah.
I like that. So if I'm just going to repeat that, and then I'm going to share. There's a lot of passion in the comments around Baye and Comedy and etc. Right? But so what I just heard you say is CDC plus gRPC is the PubSub API, and
That's
then
correct.
CDC plus Comedy is the streaming API. I like
Yes.
that. I'm going to remember that one. All right. So I hear, so Beach is saying Comedy Bio is such a pain on the streaming API. You can only have one listener versus multiple with PubSub gRPC, and Comedy Bio locks up too. Is that why that recommendation is there, Gala?
Yeah, so as I said, PubSub is basically using HTTP2, which is basically provides multiplexing. That means the same connection can be used for listening as well as publishing the events. And the same connection can be used by multiple subscribers. Yeah.
All right. Um,
Yeah, I see one question from Gaurav as well. So MuleSoft provides both type of connectors, one for CDC over Comedy, which will enable long polling, and the second connector is PubSub API for PubSub API over gRPC. So both are supported by MuleSoft.
okay. Awesome. And you know, I kind of ruled out platform events because we didn't need to customize the payload. There's a question here that's saying platform events will have some daily limits as well. So would you also say that that is another reason not to go with platform events and use CDC because of the volume, because of the 50 million records that we're talking about?
As far I remember, both share the limits. CDC and platform event both share the limits of the platform.
Hmm.
But we'll have to double check. Yeah,
So we'll need to double check that. All right.
yeah.
Awesome. There's a question here also on, I kind of ruled out batch processing, right? Because of the near real time. I have a question here from Ernst Jan, who is asking, do we know of any best practices to avoid those. So it says here, say if a near real-time account sync is needed to SAP, how not to... Arjan, could you maybe like rephrase it in the chat, because it says here how not to blow off a fire, forget near real-time integration. And so Golal, unless you understand what he means, what he's getting at.
If I understand it correctly, then he's talking about first come, first serve. So FIFO kind of mechanism for the events, and at the same time maintaining high throughput and low latency. For that kind of requirements, we can use uh, Heroku Kafka or Kafka as such, where we have partitions and we can maintain the event sequence from the record level, not throughout the object level. But it is a little bit complicated solution, which we can discuss in some other day.
Do you know, like, and I'm kind of trying to think out loud here. Do you know that what if we said, okay, we could do a batch, but we would do a batch every minute, for example? Like how, what would be the implications of that?
The first problem is the batch will use a different type of API. It will be data API, which has a different type of limitations, platform limitations, than CDC limitations. CDC is more robust, more performant, and it has more limits than data APIs, as far as I remember. That can be one of the reasons why we should go with the event-based sequencing. And it is more about the business requirement. So near real-time requirement was one of the considerations which we have. But if we have a batch type of requirements which can sync over a day or in a week, then it's absolutely fine to go through the batch-based processing.
Okay. Awesome. So comment here from David, have to have an assumption that the business does not want to expose the database outside of on-prem. Yeah, you're right. That's kind of typically what I always assume with on-prem anyway, especially with that kind of database technology. Do you have any experience or any reaction to that, Galo? What's your take?
I think it's more about. Sorry, I think you're talking about total cost of ownership, right?
Yeah, for example, or it's more like as part of this solution, like what would happen? Like in my view, or maybe I can take this. So the way that I'm interpreting the comment is, it's also a good assumption to say that the on-premises database cannot be exposed outside, and that might be like another driver to put like a MuleSoft in between, rather than connecting directly between Salesforce and the database.
Yeah. So MuleSoft can help us in means obviously it can help us in abstracting the backend systems. At the same time, we can introduce a second layer of a queuing mechanism like Kafka, which will give us more freedom about pub/sub mechanism, and then we can distribute the same stream for the particular object without adding multiple subscriber for the particular object. For example, account CDC. So we can consume it from MuleSoft and then publish it to Kafka. And from Kafka, we can add multiple subscribers for different backend systems. In this way, we are not hitting the Salesforce platform multiple times for consuming the event, and we are able to address or we are able to fulfill the requirements for different backend systems.
Understood. Yeah, thank you. Another question here. So I was considering Data 360 almost as an integration layer and then discarded the idea due to connector limitations. Yes, and the absence of zero copy. Does a route of on-prem to MuleSoft to Data 360 to Salesforce make sense? And also the question, why was Data 360 the first choice? And let me take that one first. The reason that I wanted to think through the Data 360 is that we're often seeing Data 360 as part of the landscape, and I just wanted to kind of already do the mental gymnastics so that if it actually turned out to be a part of the landscape, which I don't know based on the requirement, that I would be able to justify why I would or I wouldn't incorporate that into the mix.
Yeah, one important point, the connectors are still available, but we are not talking about ingesting the data into data cloud. We were talking about zero copy mechanism, and that's where we are still evolving. And in near future, we may have, we don't know. But from the ingestion perspective, we have all the connectors which can ingest from on-premise database also.
Yes, absolutely. All right. So the next question that I'm seeing here, it's a question from Squire, and I have to say that it did cross my mind at some point, and then I let it go. But what's your take, Gulal? Like, would you consider a Canvas app as a solution option here as well to expose that data back into Salesforce?
Mm, sorry, Canvas app. Uh,
So this is, let's say, more like a kind of UI mashup type of pattern. I'm going to say, from what I remember, sorry, it's Ayush. From what I remember, is that I don't think that Canvas is a likely contender because it also requires some kind of web UI and some changes to be made to that, and then it's pretty much the UIs talking to one another. So I don't, and it's more of a request and reply. So yeah, so I don't think that this is a good idea myself.
yeah, in that sense, Event Bridge can be a good option. Deep has asked that question. So Event Bridge is just for AWS apps. So I think that can be more reasonable here.
You think that's a good option?
That can be one of the options. We have AWS Event Bridge, and then we can publish the events directly to AWS, and then the apps hosted on AWS can consume them.
All right. Another question on CDC from Beach here. Do you have any views, Gulal, or best practices on managed subscribers and CDC enrichment?
Yeah, so Salesforce has rolled out a new feature where we can enrich the CDC packets and we can add additional fields as well as we can do some kind of filtering, basic filterings. So that is out of box feature available. We just need to configure and play.
Okay, perfect. And then another one that I think is pretty much going to be in your wheelhouse from Belwant. In large enterprises where integration landscapes evolve rapidly, how do we decide when to strictly enforce API-led connectivity versus adopting event-driven or hybrid patterns?
Yeah, I think it's a business case, a business use case driven. So API-led approach has its own advantage versus event-driven API, event-driven based approach. Both have pros and cons. We need to decide which one is the best option for a given business requirement. So there is no hard line I will follow.
So are you telling me that the answer is it depends?
Yes.
You are. I love it. All right. So another question here from Gaurav saying, if we write back the data into the external object, does that sync it back in the source system automatically? And I think I can answer that. I think the answer to that is yes, right? That is also why we like the OData 4.0 protocol. It was meeting our requirements to be able to update that data back in from a single UI. So I hope that answers the question. Another one from Gaurav, and maybe you can shed a little bit more light on this. So we had like this integration with MuleSoft in the middle, and the question here is: so Salesforce publishes the event using the streaming API, and then MuleSoft subscribes using PubSub. Is that also how you see it? Is that the correct way to think about it?
Yeah, because of the platform limits, if you don't want to base those limits, then better to have some kind of pub-sub mechanism implemented with MuleSoft so that you are not hitting the Salesforce platform again and again for different type of backend systems.
Okay. All right. And then another one that I think we talked about when we were discussing this up front. So, can you say a little bit talk about the layer that is going to be handling data item potency and retry mechanisms in this orchestration? And while you're at it, maybe just for people who don't know what it is, just briefly explain what item potency is.
Yeah, so data idempotency and error handling mechanism both needs to be handled in the MuleSoft layer. And basically, it means if you are sending the request or sending the event again and again, it should not uh, corrupt the state of the target system. So if that's the case, then it can be handled in MuleSoft layer, and of course the error handling mechanism with all the patterns which we have for asynchronous processing needs to be implemented, and then we should be good. Like watermarking, restart from where you had left, which will be which can be done with a replay ID on the CDC side, and from the target side on the backend system, if there are some errors, then you can handle them. You can store them into the persistence layer so that you are not missing the sequence of the events while processing it. And of course for the retry mechanism.
Yes. MuleSoft to the rescue. Squire to the rescue as well, saying it's important to remember that this exercise is a 20-minute case study, that the full list of assumptions and considerations would be so much broader, covering security, data analytics, and all the other domains. And of course, that is true, right? So thank you for commenting that. And then Ravi is saying iframe will work for UI as data virtualization, and that is true if we have some kind of web front end on that database, right? But if it's a pretty old school on-prem, maybe there is no kind of web front end. So yeah, we don't know that. And then you also so anyway, wanted to raise those comments, and then I think maybe a good last question to end it on, bringing it into the agentic era. How do you feel that A2A will change the data virtualization landscape? Can we expect agents in front of databases, including on-premises ones, and could they potentially be the interface for the solution?
Well, see, A2A is more about agent-to-agent communication, agent-to-agent protocol. So that can be leveraged for communication and orchestration between different agents. I see it more like an MCP tools. If you have a database, then agents can consume those MCP tools. But data virtualization is again a different um, pattern, and I don't see all of them competing with each other. They all three are different patterns for different purposes.
Awesome. Yeah, I think the way that I could potentially imagine it, but I don't know how it would work technically, is that instead of if I'm not looking at a UI myself, but interacting with an agent, then I would ask the agent, what are the shipment records for this customer? And that it would talk to some agent that has access to the on-prem database that would then hand it back that data and tell it to me or something like that. Potentially something to try out in another episode. Let me just bring it back because we're reaching the end of our time here today. So the invitation to learn about integration patterns, the document linked here, the document written or updated by Gulal, integration strategies. We talked about a few of the patterns in here. There's a lot more, so please give it a read, and then, of course, share your feedback. So let us know what should be the topic of the next episode, and let us know how it went. And thank you very much for your time. I hope you enjoyed it. Thank you, Gulal. Thank you, everybody who asked questions and interacted. I really enjoyed it. Thanks a lot.
Thank you.